When you are graphing an exponential, it's usually a good idea to start with a table to get an idea of what's going on. So we have the equation y equals 5 times 2 to the power of x. Let's start by figuring out what happens when x is 0. Remember that 2 to the 0 power, or anything to the 0 power for that matter, is just 1. Therefore, y times 2 to the 0 power is going to be y times or 5 times 1, or simply 5. So we have our first value. Let's put that in here. And that'll leave us some room to go in either direction. So now let's say I want to evaluate for when x is equal to 1. That's going to be 5 times 2 to the first power, 5 times 2, which is 10. If I keep going with this, y is equal to 5 times 2 squared for the second power when x is equal to 2. So that's going to give me 2 squared is 4. 5 times 4 is 20. So let me fill a couple of these in. So when it's 1, I get 10. When it's 2, I get 20. And by now we can start to recognize the pattern. And it makes sense that each time I add 1, I'm effectively multiplying by 2 another time. So I can use this pattern to help me, not 3, 2. I can use this pattern to help me finish this off. So when x is equal to 3, this is going to be 20 times 2, or 40. When x is equal to 4, I'm going to get 40 times 2, or 80. It's also going to go the same way going the other direction. In other words, to get from here to here, I had to multiply by 2. So to go the opposite way, I effectively have to divide by 2. Therefore, when x is equal to -1, I would do 5 divided by 2, which is, I could express that as 5 halves. It's equivalent to 2.5. If I go to -2, then that's going to be half of 5 halves, which is going to be 5 fourths. And notice actually what's happening here is the denominator keeps doubling. Denominator doubling is equal to cutting something in half. So when I'm at -3, that would be 5/8. Now I'm getting down below 1. So that gives us a good idea. Basically, I would recommend doing 1 or 2, and then you can let the pattern take over. Hope that helps. Thank you.